Ever wonder how a chiller cools an entire building? Today, I'm going to break it down in the simplest way possible. A chiller's job is to remove heat from water. That cold water then travels through pipes to air handlers or fan coil units throughout the building. The air handler blows warm air across the cold water coil, and that removes heat from the air. That's how large buildings stay cool. But here's where it gets interesting. Inside the chiller is a refrigeration cycle, just like an air conditioner, but much larger. It starts with the evaporator. Warm return water from the building enters the evaporator. Inside the evaporator are refrigerant tubes. The refrigerant absorbs heat from the water and boils into a vapor. Now the water is colder, so it gets pumped back into the building to cool rooms again. But now the refrigerant is hot vapor, so the compressor steps in. The compressor raises the refrigerant pressure and temperature. Then the refrigerant moves into the condenser. The condenser removes the heat from the refrigerant. Depending on the system, that heat gets rejected either through air using condenser fans or through water using a cooling tower. Once the refrigerant cools down and turns back into a liquid, it passes through an expansion valve. That valve drops the pressure and temperature of the refrigerant. Then the cycle repeats over and over again. Now here's the important part. If water flow is lost, the chiller can freeze. If condenser flow is poor, head pressure rises. And if refrigerant charge is low, the chiller loses cooling capacity. That's why chillers rely on safeties like flow switches, pressure sensors, temperature sensors, and oil safeties. Modern chillers can cool entire hospitals, data centers, military facilities, and skyscrapers 24 hours a day. And honestly, they're one of the most impressive HVAC machines ever built. Follow for more HVAC, engineering, and tech breakdowns.